Okay, so the examples we've seen so far were fairly small, like 2 equations and 2 variables, 4 equations and 4 variables. What if we even just had like 5 equations and 7 variables? Let's think about how we would write that down. And I want you to keep in mind that in applications of linear algebra, there could be, you could have 75 equations and 100 variables, or 1,000 equations and 1,000 variables, So just to imagine this is going to could be much bigger. And just think about if we wanted a general equation in 7 variables, linear equation, what would that look like, right? So you could say, well, it'd be like ax plus by plus cz plus d, I don't know, u plus e v plus f w plus, I need another variable, gt equals h. That would be like a general, so the u, so the x, y, z, u, v, w, t are variables, a, b, c, d, e, f, g are coefficients. We start to see the problem, right? Like we go to the second equation, it would be ix plus jy plus kz plus dot dot dot. Third equation, fourth equation, you're going to run out of letters, right? So somewhere I'm going to have like alpha x plus beta y plus gamma z plus delta u plus dot dot dot. Anyway, so something is clearly, you need to be a little more systematic, right? That's my point here. And so the idea, I think, the first idea is to use subscripts. So for example, a better thing to do here would be, the first equation could be a1 x1 plus a2 x2 plus a3 x3 plus a4. I'm just going to dot, dot, dot. You get the idea, rather than having to write out 7 terms. And then this could be, well, again, this is the first equation out of like 5, so maybe I'll put b1 there, something like that. And then, well, actually, if I use b1, maybe I'm going to use y1. And then for the second equation, now you need a new letter, like b1 x1 plus b2 x2 plus dot, dot, dot equals y2. And that's not too bad. You could go up to e1 x1, e1 x1 plus e2 x2. But again, if you have 500 equations, we still have a problem here, right? You're going to run out of letters there. So in fact, you're going to run out of letters no matter what. So the second thing to notice is we can actually use something even more systematic. And you might not have seen this before. I'm sure you've seen subscripts before, but we're going to use double subscripts for the coefficients. So let me show you. So just keeping this 5 equation and 7 variable example, you would have, you're going to actually do a11 for the first coefficient of the first equation. That's what the 1 is. And then a12, first equation, second coefficient, right? First equation, second coefficient. That's kind of the way to think about that. a13 x3 up to a17 x7, and then I can still say it equals y1 or something like that, right? And then the second equation you would now start your double subscripts with 2. So the second equation, first coefficient, a21. Second equation, second coefficient, a22. Second equation, third coefficient, a23. Second equation, seventh coefficient, a27, and then x7. Okay. And then notice that this now generalizes, right? So if we had 5 equations, the last one would be a51 x1 plus a52 x2 plus so on. And this works for any number of equations, any number of variables. Like if we had 500 equations and 500 variables too. Actually, I have to be a little careful there because if I had like, you might want to use commas. You could actually, so a11, you can use a11, or you really probably should write a1 comma 1, but nobody really does, because if you want the 270th equation and the 112th coefficient, right, that would be a sub 270, and then you need a comma, or else that even looks like 270,000 112, but it's really 270 comma 112. But in general, we tend to not write the comma because we just sort of write that. So, and then we tend to write, so then we'll say like a sub ij is the ith equation, is the coefficient, and it's the ith equation, the jth coefficient. Sounds kind of funny when I say it that way. Okay, and in fact, what we're really going to do is we're really going to write things in terms of matrices. So if we wanted to take something like this and write either a coefficient matrix or an augmented matrix, right? What we would have is we would have a11, a12, a13 up through a17, a21, a22 up through a27, down to a51 through the last one be a57. And then I can augment that with, what did I use y's? Yeah, let's say y1, y2 through y5. Right, and so this is more general. Again, this part without the augmented column is just the coefficient matrix, and the whole thing is the augmented matrix. And now aij is, well, maybe I should say this. We have rows and columns, right? So this is row 1, row 2, row 3, up to row 5. This is column 1, column 2, column 3, up to column 7. And again, I think of the augmented column as being different. But now what does aij represent? Is the entry in the ith row and the jth column. Okay, so that's just some general notation. Yeah, maybe one last comment just to throw it out there. We can also use summation notation if we really want to make things even more concise. Like for the 5 equations and 7 variables, for the first equation, we could actually write something like, so remember your summation notation, we could actually write something like a1j xj, summing that from 1 to 7 equals y1 for the first equation. All right, this is the first equation in the 5 equations and 7 variables. And then if we wanted the fifth equation, then this would change to a 5 and that would change to a 5. And so you could even write the whole system, if you wanted to, as the sum from j equals 1 to 7, a sub ij xj, the sum equals yi. And then maybe outside here, you'd say I goes from 1 to 5. So I won't write systems that way, but it's kind of, mathematicians, again, if you had 500 equations and 500 variables or something like that, you'd want some nice, concise way to write this. And it's kind of a nice, so you don't have to write out all terms or use dot, dot, dots and stuff. But that won't be a big deal. I just wanted to put that as a final comment. Okay, end of this video.